A little bit different concept. Some of the formulas are close to, or they have some of the same variables as your surface area ones. That's why I wanted to get your quiz done before we switched and talked about volume. All right, volume is the volume of a three-dimensional figure is the number of overlapping unit cubes that would fill an interior. I've got different size of cubes here to show you. A few anyway. I've got a little cube, quite a few that are just 1 centimeter by 1 centimeter. So this is a cubic centimeter. If it's an inch on every side, it's this size, a cubic inch. I have a box if I can grab it real quick. A box that's about 1 foot by 1 foot by 1 foot. Got it locked in here so no one takes it. All right, let's see what all I got stuff inside it. Okay, this box is about 1 foot by 1 foot by 1 foot. So as far as size, I know when we do problems, we're really just looking at numbers, but I want you to do a comparison. This is a cubic inch. This is pretty close to a cubic foot, 1 foot every direction. How many of these would it take to fill a cubic foot?
144.
144? No? 12?
No.
Obviously not 12, because if it were 12, it would take 12 just to make one row across the bottom. So then are you thinking
Oh, it's probably got to
another
be.
row of 12, another
No.
row of 12?
Wait.
Oh, we need down to 7. Okay, so that 144 really just fills the bottom layer.
No way, it's 1,728.
Right, so then you'd need 12
That's what I
layers
said
of that.
first.
So it's 12 times 12 times 12, okay? So that conversion, if you're converting units, you need to be careful because it's a lot bigger than what you're thinking originally because it's 3 dimensions. All right, prisms are done really the way that we just did that. Length times width and then height works if it's just a right rectangular prism. And you probably learned that volume formula back in upper elementary. Okay, take length times width times height. That is only for that kind of a prism. If it's a cube like we were just working with, the same measurement every direction ends up being the side times the side times the side. What if it's not those nice shapes? What if it's a triangular prism or a hexagonal prism or something like that? Well, what we will do is take the area of the base, so we're filling the bottom, and then multiplying by the height. So that tells you how many layers there are as you go up. I've got a kind of skinny rectangular solid here. Try and dump in some of my cubes. Let's see if I can get them in there good enough that we can tell how many it would take. Kind of close. I'm missing like 1 row.
Just fill it all
So
the way.
there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's room for 1 more. So 10 going this way. There's 4 and room for 1 more, so 5 going the other way. So if it's 10 and 5, how tall is it going to be? How many layers will I need going up? And I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going up. So what were the dimensions?
10. 5. 5.
If I'm holding it this way, 10,
10,
5,
5.
and
10.
10. So how many cubes do I need to really fill it?
About 500.
I need 500. Okay? 10 times 5, 50 for just 1 layer, and then 10 layers of it. Okay? So you're taking base area times height. So even a strange prism, if I would tell you the area of the pentagon, let's just make up a number, say the area is 60. The area of the pentagon is 60, and then there are 10 layers, so you need
600.
600. Now how would you really calculate the area of the base?
You would take a half apothem times perimeter.
For this one, correct. What if it were this base?
Uh,
Probably 1/2 base times height. You could do 1/2 apothem perimeter, but I'd say most of you probably are thinking total height. So find the area of the base, multiply by how many layers there are. Same with the hexagon. 1/2 apothem perimeter, and then times the height. So prisms, where it's the same amount going up all the time, if you know the area of the base, multiply by the height, and you're done. Let's do a couple calculations. You need an example of a rectangular prism.
Yep.
Okay, find the volume of the prism, round to the 10th if necessary. Now this shape, you really could use any pair of sides as the base. When it says base area, that doesn't mean the area of both faces. Think what we were doing. If you know the area of one of them fills the bottom, and then layer it going up. How much? 195?
I see it first.
You're just taking 13 times 3 for the base area, and then times 5. Okay, another prism. Let's do a cube. I didn't give you a picture, but it's a cube. You can draw that if you need that example. Volume.
3,375.
How did you get that?
I just took 15 times 15 times 15.
Right. So 15 times 15 times 15. You could use the 15 cubes specifically for the cube. Does the same thing.
Wait, how do you put cubed into a calculator?
Oh yeah, do you have a cube button?
We have a squared button.
You have to press
Okay,
it.
do you have one that is what's called a caret? Does it have that on there? Okay, that's a like general raised to the power. So you go, usually you go 15 raised to the 3rd power. You might have to hit equals or answer. Does that give you 3,375?
Yeah.
No, give me a syntax error.
I'll help you out there, great.
Now, while we're doing that, you might try and go backwards, because probably there will be a problem where I give you the cube's volume and ask you how long is every side. So are you able to go backwards? Can you take the 3,375 and you have a cube root key?
Oh my, wouldn't that just be a square root of that? Oh.
Is there a cube root key on yours?
Well, let's find out.
And if not, there might be just a general root. Maybe it even has a variable up here, like x or y. Okay, if you use that one and then tell it 3, some of yours you might have to go the other order. Do you put the 3 in first?
Wait, I think I got this right.
Okay, try one of these two, depending upon your calculator. If you have that general key, you might have to put the root in first and then the number. That's the order yours goes.
Wait, but no, I don't think I got it right.
It should come out with what for the answer? 15. I think most of yours right in the screen.
Well, what the heck? What?
I got it.
Grant, show me. Show me, Grant. Do you? Oh, yeah. Oh,
Okay, the raised to what?
Oh, shear me. Oh, shear me. He's like, oh, I'm next, I'm ready. I'm ready to be showered.
I've never seen it.
Anyone need help on the calculator? Okay, everyone figured out their own calculator? All right, let's go to another one. Here is a right regular hexagonal prism.
So we move on to prisms.
So it is a prism.
Don't
It's
worry.
a right prism, which means it's nice, straight up and down, perpendicular.
Don't, I'll figure this one.
You have to find the base area. I didn't tell you that.
Gosh, but figure this out record speed.
Don't don't shout it out, please let everybody have a chance to figure it.
2.
Draw what shape the base is. Work on finding the area of that. You're gonna take that times the height.
Wait, say that again?
Find the area of the base, which is a regular hexagon.
Duh.
Gotta figure out the apothem.
Right, it's shared.
And that's your final number. The answer right up, so I'll just turn on here. See if anybody agrees with it first.
It only took me like 10 seconds.
Evidently, the answer was your apothem.
Yeah, it was like 9 divided by 10 of 30, I think. I don't know what I put in there. Oh, whoops. I probably don't have right answer.
No, that doesn't look right then. Is it divided by or is it multiplied? Let's see. You're doing a 30-degree angle. You wouldn't have a 9.
Yeah, it'd be a third.
You-
Oh, gosh, dang it. This is
Base area. Oh, that's what you said.
Shut up, Kelsey.
Okay,
Thanks, Kate. Appreciate it.
let's compare apothems. Jake, what do you have for an apothem? Good one. And this was what Connor was talking through with me. Does he have the 30 in the right place? I think so. 4.5 because the whole side was 9. So tangent of 30 over 1 is 4.5 over A. He'd have to divide correctly. If you were doing the 30, 60, 90, wouldn't that just be 4.5 times the square root of 3 for the apothem? Okay, so let me see what our final answer is, and then we'll talk through what issues we had. Base area and volume, complete decimal, 2,525.3? Yes, no?
No.
Okay, did you get the apothem correct? And if you didn't do this form, what is that in straight decimal numbers? 4.5 times the square root of 3. 7.8 is what it would round to be.
Okay, that's what I like to do.
7.80 is what it would round. Or actually, it wouldn't round to that. 7.79 if I go hundredths. Okay, but you're probably not that far off. Okay, then all you're doing is sticking that number in to find the base area. And 121.5 times the square root of 3. Base area was like 210.44.
Wait, where's the 54 from?
Where's the 54? This is probably 1/2 apothem times perimeter.
Got it.
The side was 9, so times 6. And then to find the volume, you took that base area. If you wanted that in decimal, you could put it there. Times 12. All right, again, writing down step by step, keeping track of what you're doing. More questions to clarify that one? You get it figured out? Yeah. Okay, Jake, you're staring into space. Did you get that? No? Okay, which part did we get stuck on? The apothem? Didn't do this part? Okay, do you know how to do that part? All right, let's see what I have next for you. I didn't do a lot of examples of each one, but here, find the volume of a triangular prism. It has a height. The height of the prism is 9 yards. The base is a right triangle, and the legs of it are 7 and 5. We know we need to find base area. Let's just draw the base to start with. What shape's the base?
A triangle.
A right triangle.
All right, that's what I meant to say.
Okay,
Sorry.
so draw yourself a right triangle. Put your right angle in there so your mind's thinking, okay, right triangle. The legs of that are 7 and 5. Find the area of that. That's our base. What's the area of that triangle? So you're doing 1/2 7 times 5 for the base area?
Mm-hmm.
Okay, so base area is 17.5. Okay, now the volume was that base area times the height. Height of the prism, okay, not height of the triangle. So 17.5 times 9 is how much?
Approximately 157.5.
Okay, 157.5.
1, 2, 3.
What kind of units do we have for volume? Cubed, and in this case it's yards. So cubic yards. Question on that one. The base was a little bit easier than our hexagon. Question? All right. There's our answer. All right, let's talk about cylinders. Cylinders are kind of like prisms because you use the same amount in every layer. What's the base area going to be? How do you figure it?
Pi r.
Pi r squared, and then you're going to multiply by the height. So that's the formula that we have up there. In the end, when you think about everything, it's pi r squared times height. So let's do the volume of a cylinder. The diameter of it is 16 inches. So what's the radius?
About 8 inches.
8. And then the height of 17. And the answer, I'm asking you to go both ways, in terms of pi and rounded to the nearest 10. Make sure we can do both. Cylinder. Okay, what do we got? 1,088 times pi?
Yes, wait.
That's in terms of pi,
And then in terms of not pi,
is 3,418.1. Okay, that one easier?
Yeah.
Yeah.
The cylinder is going to be easier because the base is always a circle. We don't have to think of the different formulas.
yeah.
Now, what kind of a cylinder is this one?
It is a not regular cylinder.
Okay, it's oblique, okay? Now, how are you gonna find its volume? Same way, just when you would layer things, when you would make layers of cubes, you'd wanna go real thin, but they would just be offset a little bit. What's the height that you're going to use? You want the perpendicular height or like the slant height?
Perpendicular.
The perpendicular gives you the layers, okay? So find the volume of what's up there. Again, both ways. base area is gonna be pi times radius squared, which is the radius, multiplied by the perpendicular height.
Have it with Frank.
Is there a number that you can multiply by pi and have it come out not?
Can you do what?
Is there a number that you can multiply by pi and have it come out not decimal?
Because pi is a decimal that keeps going, it doesn't repeat, doesn't even terminate ever, doesn't stop. So, no, there's no way you can do that. Pi is an irrational number, which just means it keeps going without stopping. Okay, so what'd you get? Get those numbers?
You got that. Didn't you have to draw it?
Thumbs up or down?
Great.
Got it right?
The cylinders.
Okay, cylinders are pretty easy to do. How about if I tell you the base area of the cylinder is 121 square centimeters, the height is equal to twice the radius. Figure out the radius if you know the area of the circle. You should be able to, each of you think and figure out without telling each other. What's the radius? What's the radius, because you need that to find the height, to find the volume. If you're stuck, start by writing down the area formula for just a circle. The base is a circle. And that area of the circle is 121 pi. That's your radius.
Okay, got it with Frank.
What was your radius?
Wait. 11? No.
11 was the radius. So then the height would be?
21.
Height is twice the radius. So the
21.
height is
22, excuse me.
22.
You knew what I was talking about, Miss Frank.
So now you should be able to calculate. Pi times radius squared times 22. Should come out to be, suspense is killing you,
Yeah, it is.
2,662 times pi, or 8,362.9. Okay? Cylinders good? All right, the next idea, you know those composite figures that you didn't like? They're a lot easier in volume. Because if you are trying to figure out how much will this total thing hold?
No!
Oh no, make the hemispheres instead.
Did it crack, Miss Frank?
I don't think it did. Sometimes
did.
they do. And they're not actually cheap. Okay,
How
so
much?
as far as how much they're holding,
Can I buy one?
if you know how much this holds
rich,
and how
Grant.
much this holds together, just add together the volumes. Okay? So you have to do just each one separately. Okay? So what would we multiply to do the volume of that bottom prism?
8, 4, and 5. Which you
Times
multiply
4 times
together,
5.
get like 160.
Did you do that already? Okay, and then how about the triangular part?
No.
You're not gonna multiply 8, 8, and 8. You know?
I
What's
could,
the height of it?
I bet it's at least 6.
So I heard it back there, quick, 4 square roots of 3. Getting the idea of the 30, 60, 90
oh,
that we keep doing over and over and over?
Yes,
it's
Miss
on.
Frank.
All right, so 1/2 times 8 times 4 square roots of 3 would be its base area. And then, what's the height of that prism?
4.
The 4 would be the height that you would use, because that's the thickness, the distance from one triangle to the other. Okay, so those combo shapes are gonna be easier. When would you subtract? You would subtract if you're trying to take something away. Remember the ones we were scooping away? You know, that hemisphere was out of the one we did today. In that case, you would subtract the volumes. So it's, if it's added on, or if it's like scooped out or hollowed out, I guess this kind of thing, to do the volume, you would subtract the small cylinder's volume from the big cylinder's volume. So those actually will be easier. Okay, let's get this is one where we had to subtract, but we need to go through a couple more shapes, or 3 more shapes actually. Okay, the pyramids, it's almost like doing a prism, but think about each layer. As you go up, it takes less and less every time to fill it. Okay, the relationship there ends up being 1/3. And I'm going to show you with some water, if I do it quickly.
Oh.
Do you have water?
I do.
Yeah, Grant, look at there's a faucet right there.
Oh, duh. LOL hard.
I don't get it.
All right, so if that 1/3, that would mean if I would fill this pyramid up 3 times, it should fill the cube. As long as they have the same base. And is it the slant height or perpendicular height? The perpendicular height is what we're gonna need, not the slant height.
Oh.
So let's see if it comes out.
I bet it's only Miss Frank.
I bet it's only 2 times. I bet it's
You
only
just
2.
do? Yeah, the water's been sitting in the pipes there for a long time.
Drink
I
it.
can speed it up a little bit.
Don't make a mess of Miss Frank.
I know. I moved some papers
You're
away. Okay. So there's one. Oh, must have a little hole in it.
Well, we're gonna get accurate.
That's not gonna be
data now.
accurate, no.
I'm
Oh, spill it back into the big
trying to
triangle.
catch it.
Oh my gosh, that is pretty cool.
All right.
And those are
Nothing's
expensive.
perfect, huh?
Nobody's perfect. You live in your.
I'm like the opposite, but that's okay. You should have filled it with serum, Miss Frank.
I should have.
Yeah.
Then we could have
Since I wasn't
drank
gonna
it.
drink it anyway.
Oh.
Came pretty close, I don't know. I must have overfilled that second one with the leftovers. All right, let's see if it goes backwards the other way. There's one,
Oh
two,
my gosh, this data is just not accurate whatsoever. No.
three. I did better going that way,
Fairly close.
fairly
Miss Frank.
close. So what might not be exact?
The thingy is that
Oh,
like.
see, notice the plastic, it's not quite.
Where- That's because you probably
It's a little
dropped
bit
it, Miss
wider.
Frank.
I might have, and I guess I don't know if they're the same height or not.
Are they?
There's
I'd say
water
they're
all
just
o-
about
there's
the same
water
height.
all over the desk.
Miss Frank, you
Okay.
chose my desk for a
I
reason.
get
didn't you?
Alright, so to point out that the fraction that's up there, the 1/3 in the volumes, it's how much it holds. It's not because if it's a triangle or anything, but it's the relationship there. Okay, so you might get mixed up unless you focus on that fraction is 1/3. So let's do a pyramid. Rectangular pyramid. The length is 11, the width is 18, the height, does that mean the slant height or the perpendicular height? That means perpendicular, yes. That's the height you want when you do volume. You want the slant height for area, or surface area, but the perpendicular height for volume. So what do we need to multiply, and how do you do 1/3?
1 divided by 3.
Okay, can't do that. So you probably enter with the fraction key. You could do the multiplying and then divide by 3 in the end. See if you come up with the right number.
There's a fraction key.
On many of these
Wait,
calculators.
so
it
just
is.
18 times
Yeah.
11?
Something right there.
Oh.
That looks like a mixed number. Okay, can you get the right number, 1,518?
Miss Frank, just wait. My goodness, Grant.
And these
My
are
way got
kilo
it.
units also. Okay, got it?
And Michael's
Question,
like,
Kate?
no.
Did you have a question? The base of the pyramid and the length and the width, it's a rectangle on the bottom.
So it's just 18 times 11.
Yeah, so it's like this one,
Equals
so just
198.
18 times 11 to be the base area.
Kelsey doesn't
Then times the perpendicular 23,
Kelsey just
the
doesn't
height,
get it.
and 1/3 of that is
So could you? No.
Could you do what?
So you can just do 11 times 18 times 23 divided by 3.
Can you do it that way? Yep. Okay. Alright, and the volume of this square pyramid, how do you do the base area? 9 times 9, and you're gonna multiply by
14.
14, and then take 1/3 of that.
Beep boop, beep boop.
Okay.
378.
Got it.
That's it.
Alright, and let's just talk on this
378.
one. You're gonna have to find the area of the base, so you'd have to find the apothem. You have to do 1/2 apothem perimeter, 6 squared root of 3. The height of this one, it says it's equal to the apothem. So that again was 6 square roots of 3. So I'll kind of quickly just go through that one. So that we can get the last two formulas. The cone is 1/3 base area times height,
It's
just
the
like the
same
pyramid. But what shapes the base?
Circle.
Circle. So find the base
Circle.
of the circle. Yeah, you know.
So if you want to stick that circle formula in, the exact formula for a pyramid or for a cone's volume, 1/3 pi r squared times height. And again, if we're keeping it in terms of pi, you're going to multiply the radius squared times the height, divide by 3 or take the 1/3, and then that with the pi on it. Can you come up with 245 pi? The radius was 7, the height was 15, and since they wanted it in terms of pi, I just multiplied 15 times 49 times 1/3. That should be 245. And then multiply by the pi to get the decimal. Find the volume of this cone.
So the radius is 16, correct?
Radius is 16. Height is
Oh, we don't know.
unknown.
Unknown.
I gave you the slant height. So what would you have to do to get the perpendicular height?
16, 34 squared minus 16 squared. You can get, and then you can find the square root of that number, which
Okay.
would be
Right,
So
because
30.
the 34 is the hypotenuse. When you do your
Take
Pythagorean
16
theorem, you gotta
squared
get that right.
times 40
I got 27.
times
30?
1.
Wait, do you, wait.
Final answer.
I don't think that's right. It's right.
I don't think that's right. Are you just trying to find the height? 16 squared plus height squared equals 34 squared.
No, I think I was trying to find the whole volume of the cone.
Well, don't use 34 as the height.
Oh, I was
we need
thinking
to
that you
find the
just had it there
perpendicular.
wrong. Got it.
All right, final volume, how much it holds are those numbers.
I got pretty close. You know, like 1,000 off.
Okay, your last formula is volume of a sphere. You see what it is on your notes? You turn the page, the sphere is in the 10-8 section.
Yeah, I bet the sphere is just super easy.
A sphere is 4/3 pi r cubed. And you might want to highlight that cubed because this is the only formula that you have radius cubed in. So I'll guarantee somebody's going to goof up.
Can you say it again?
Grant, it's on your L paper.
I know, but what did you want us to highlight?
Highlight the radius cubed. Radius cubed would be
Thanks,
taking
Kate.
like the length, width, and height. That would be like a cube idea, but then times 4/3 and times pi. Now, how are you going to multiply by 4/3? If you have a fraction key, it's really easy. Or you can do your 4 divided by 3. You can multiply and then multiply by 4 and divide by 3. Let's see how we handle it on this one. Find the volume of this sphere as a simple example. What's the radius? 12. Okay, so you're going to have to cube 12. Take it times 4/3, which you could do multiply by 4 and divide by 3. You need 2 steps.
2,304 pi.
That with pi should be
2,304 pi.
I don't know if you were.
2,304 times pi.
Giggity.
That was just taking 2 cubed, or 12 cubed, 12 times 12 times 12, times 4/3. Now again, you could use that cube button or just multiply it 3 times.
Gosh, we're gonna do it. Oh my gosh, girl.
Okay. I know we're kind of running out of time. I wondered how this would work. How would you do a hemisphere?
Find the whole thing and divide it by 3.
Even better. 2 divided by 3.
So then combinations with hemispheres, you should be able to do some combinations.
Okay, Kelsey, go into
Okay,
the
this assignment's a mixture of different problems on different pages.
No.
Okay, so let's write it down real careful.
Oh, she's still what? Why? Because she took a bunch of pictures.
Now, if you count up, it's not as many as you think. Remember that 11 and 12 that we did surface area of? Now you just do volume.
Don't tell her I said that. I'm not going. She's my cousin.
She's someone.
Okay. The first page are the prisms and cylinders. Second page are the pyramids and cones. And the last page has spheres and hemispheres. Probably a combination here or there. But keep in mind the combinations, you're either adding volumes together if they're like stacked together, or you're subtracting volumes if you're taking something of the big one away. We'll spend some more time on volume
Oh my gosh, we only
tomorrow.
have like 3 more seconds.
We made
No,
it.
no, we have another minute.
Dang.
No, I think she's telling. That was 3.
Are you serious?